NASA is still classifying it as a comet. They're saying that there's nothing radically unusual about it.
What if an interstellar object whirling through our solar system is actually a nuclear-powered spacecraft sent by aliens?
The moment NASA published its latest report on 3I Atlas, the astronomical community froze. For years, scientists had suspected that this object, first spotted hurtling through our solar system with an unusual trajectory, might conceal something far stranger than a mere interstellar rock. When the data finally emerged, the findings only deepened the enigma. The report, heavy with technical precision, yet trembling with implications, suggested that 3I Atlas was unlike anything humanity had ever observed, both in composition and behavior. Its origins, velocity, and evolving structure hinted at a cosmic story still being written, and possibly at forces or phenomena not yet cataloged by human understanding. Before we start, please don't forget to like and subscribe to our channel for more updates. The story of 3I Atlas began as a faint streak of light captured by automated survey telescopes scanning the sky for transient objects. Initially, astronomers assumed it was a long-period comet, perhaps originating from the Oort cloud, but within days, orbital calculations dismantled that assumption. Its hyperbolic trajectory meant it wasn't bound to the sun at all. It had come from beyond the solar system. That alone made it the third confirmed interstellar visitor after Oumuamua in 2017 and 2I/Borisov in 2019. Yet even in that small group, 3I Atlas stood apart. It was larger, brighter, and behaving with an erratic volatility that defied the models designed to explain cometary outgassing. It wasn't just a frozen lump venting gases. It appeared to be dynamically alive, reacting to the solar environment in ways no natural object should. The newly released NASA report outlined months of data collected from multiple observatories, including Hubble, the James Webb Space Telescope, and the Deep Space Network. The object, according to spectroscopy, exhibited a mix of carbon-rich and metallic materials that shouldn't coexist in a single body formed under standard stellar conditions. The isotopic ratios didn't match anything known in the Milky Way's chemical databases. Some of its elements seemed anomalously enriched, suggesting that 3I Atlas could have been forged in an environment subjected to immense uneven radiation, perhaps near a magnetar or within the debris field of a supernova remnant. Its structural integrity, however, implied it hadn't been destroyed by those forces, but instead somehow condensed into a stable, cohesive form. What truly captured scientists' attention was its luminosity profile. As it neared the inner solar system, 3I Atlas didn't brighten steadily like typical comets. Its brightness pulsed. Every few hours, a rhythmic variation appeared, as if the object rotated to reveal reflective surfaces or emitted periodic bursts of material. The NASA team spent months ruling out sensor errors, atmospheric distortions, and software glitches. None could explain the pattern. The intervals were too regular, the amplitude too consistent. This suggested either an internal mechanical process or a naturally oscillating surface phenomenon. But for something supposedly natural, the precision was unnerving. Further complicating the mystery was its sudden change in trajectory. When it passed within 1 astronomical unit of the Sun, 3I Atlas experienced a minute but measurable acceleration inconsistent with gravitational predictions. The report cited the Yarkovsky effect, a known phenomenon in which anisotropic thermal radiation can push small bodies, but the magnitude of 3I on Atlas's deviation far exceeded what solar heating could produce. It was as if the object responded to the sun's energy in a deliberate, directed way. The phrase non-gravitational acceleration appeared multiple times in the document, carefully worded to avoid speculation but impossible to ignore. This anomaly rekindled debates that began with Oumuamua's discovery. Was humanity once again witnessing an artificial interstellar object? NASA's scientists were cautious, almost painfully so, avoiding any phrasing that could ignite the public's imagination beyond control. Yet even their restraint couldn't hide the significance of what they had found. The internal consistency of the data left little room for simple explanations. A natural body of this size and density shouldn't produce such precision in its rotational dynamics, nor such sharp emissions of light. And its energy distribution, recorded across multiple wavelengths, indicated the presence of compounds that behaved like engineered composites under radiative stress. The NASA report emphasized that 3, Atlas's spectral fingerprint, contained traces of elements found in nickel-iron alloys mixed with organic polymers that shouldn't survive interstellar travel intact. This odd chemistry led to theories that the object might be a fragment of a much larger structure, a piece of a planetary crust torn away by cosmic violence, or more provocatively, debris from an artificial construct launched eons ago. The idea of a derelict probe adrift between stars had long been confined to speculative fiction, but the data refused to settle comfortably within the boundaries of conventional astrophysics. When the team reconstructed the object's likely path through the galaxy, another astonishing detail emerged. Its velocity relative to the local standard of rest was lower than expected. Unlike 2 I/Borisov, which raced through the solar system at a breakneck speed consistent with random galactic motion, 3 I Atlas appeared almost deliberate in its approach. Its inbound vector aligned eerily close to the galactic plane, following a course that minimized gravitational perturbations. Some analysts quietly noted that such a trajectory would be ideal for maintaining navigational stability over long distances. The official explanation called it a statistically unusual but not impossible coincidence. For many, though, that phrase only fueled deeper speculation. The report described how, as 3 I Atlas passed beyond the orbit of Mars, its brightness dipped sharply, followed by a sudden infrared flare detected by Webb. That flash persisted for exactly 11 minutes before fading completely. The infrared signature corresponded to rapid heating of metallic compounds, something akin to a short, intense energy release. The cause remained unknown. There was no accompanying debris cloud or evidence of fragmentation. Whatever had happened was self-contained, silent, and unseen, except for the instruments pointed at it. For the first time, NASA's analysis admitted the possibility of an internal energy source, though it stopped short of suggesting artificiality. It was labeled as thermochemical instability triggered by solar radiation, but even the authors admitted the model fit was poor. The implications were staggering. If 3 I Atlas possessed internal mechanisms, it could mean that interstellar space harbored objects with complex internal dynamics, perhaps remnants of civilizations or byproducts of unknown astrophysical processes. The idea that the galaxy might contain self-regulating, semi-active debris blurred the line between the living and the inanimate. It also raised uncomfortable questions about humanity's readiness to interpret what it was seeing. Science fiction had prepared people for alien contact, but not for the subtle terror of ambiguity, the possibility that something might exist between the natural and the technological, neither entirely one nor the other. As NASA's telescopes continued to monitor 3 Y, Atlas's departure, strange periodic radio signatures began to appear in the data stream. The report stated they were likely interference from terrestrial sources, but private observatories around the world confirmed similar detections. The frequencies were narrow, repeating, and remarkably consistent with the object's rotation period. When plotted, the emissions formed a geometric pattern that resembled a modulation envelope rather than random noise. Once again, official explanations emphasized caution, attributing the phenomenon to solar wind interactions or background cosmic interference, yet the timing was too perfect, the synchronization too persistent. Scientists within NASA's Jet Propulsion Laboratory reportedly debated whether to classify the object's emissions as active signals or natural modulations. The distinction was more than semantic. It determined how the data would be archived and analyzed. Labeling it as active implied a degree of intentionality, something no agency was eager to claim without irrefutable evidence. Nevertheless, the report's language subtly shifted as it neared its conclusion, referring to 3 I Atlas not as a cometary body, but as an interstellar system. That word choice did not go unnoticed by those who read between the lines. In broader astrophysical terms, the discovery of 3 I Atlas forced a reconsideration of what constituted a natural object. The cosmos was already known to create exotic configurations, neutron stars with intense magnetic fields, rogue planets wandering light years from their suns, molecular clouds capable of birthing organic compounds. Yet 3 I Atlas didn't fit within any of these categories. It seemed too cohesive, too purposeful in its behavior. The possibility that interstellar space could serve as a conduit for relics of advanced technology, perhaps long dead, perhaps dormant, introduced a new dimension to cosmic archaeology. Each observation peeled back another layer of the unknown, but none reached the core. The timing of the report's release was also significant. It arrived amid an era when the public's trust in official narratives about extraterrestrial phenomena was already fragile. Recent disclosures about unidentified aerial phenomena had primed audiences to interpret any mystery as evidence of intelligent life. NASA, aware of this cultural undercurrent, meticulously framed its findings in neutral scientific language. But the very restraint with which the data were presented only amplified their power. The absence of definitive answers created a vacuum that imagination quickly filled. Among scientists, the implications stretched far beyond the question of life. 3I Atlas challenged the foundational models of how interstellar objects form and travel. Traditional astrophysics held that such bodies were ejected debris from planetary systems, wandering aimlessly through the galaxy, but the properties observed, metallic composition, pulsating reflectivity, stable energy emissions, hinted at a different origin. Perhaps 3I Atlas was not debris, but design, not an accident, but a remnant of purpose. If so, its presence here implied a distribution of such objects across the galaxy, each carrying fragments of an ancient narrative written in matter and motion. The report detailed simulations showing how long 3I Atlas would remain detectable. Within months, it would fade beyond the reach of even the most powerful instruments. Yet before vanishing, it left behind data dense enough to fuel years of study. Every wavelength captured, every fluctuation measured, told a part of its story, but not the whole. The unanswered questions loomed larger than the discoveries themselves. What force could craft an object capable of surviving interstellar radiation for millions of years without disintegration? How could a metallic composite maintain integrity while displaying organic spectral features? And if it was not an artifact, then what kind of cosmic phenomenon could mimic such precision? For engineers, the findings opened tantalizing prospects. If 3I Atlas were indeed of artificial origin, even ancient and inert, studying its structure could revolutionize material science. Understanding how it resisted microfractures and cosmic ray degradation might inform the next generation of spacecraft design. Some speculated that interstellar civilizations, if they existed, might use self-repairing composites built to last indefinitely, drifting silently between stars as probes or data repositories. The notion wasn't new, but for the first time, it had data points to anchor it in reality. Philosophically, the encounter forced humanity to confront its cosmic insignificance in a new way. The universe was no longer a silent void punctuated by random wanderers. It might be a vast archive filled with drifting messengers, some functional, others dead, all older than humanity itself. The sheer scale of time involved defied comprehension. If 3I Atlas had indeed originated near a magnetar, or within a supernova's debris, it could predate the formation of Earth. To think that something so ancient could arrive in our skies, carrying secrets older than the solar system, stirred both awe and dread. The object became a mirror reflecting human curiosity back upon itself, a reminder that discovery often reveals more questions than answers. Even the most skeptical astronomers conceded that 3I Atlas represented a new class of interstellar phenomenon. Its combination of metallic and organic materials defied the clean categorizations upon which modern astronomy relied. It was neither asteroid nor comet, neither debris nor spacecraft, yet it exhibited characteristics of all these categories. The challenge lay in defining something fundamentally alien to existing frameworks without resorting to conjecture. The NASA report's meticulous neutrality was its strength. It documented, analyzed, and resisted temptation to hypothesize. Yet, between the lines, readers could sense the tremor of wonder that even seasoned scientists could not suppress. The report's appendices included raw data from radar imaging and light curve analysis. Some researchers noted irregularities that hinted at geometric consistency, angles, and planes where none should exist. If the object's surface indeed contained flat regions or repeating contours, they might indicate structural intent. Others argued that such interpretations stemmed from overfitting limited data. Still, the debate highlighted how 3I Atlas had become more than an object of study. It was a test of perception itself. Humanity's instruments could record its properties, but human minds struggled to categorize them without the scaffolding of familiar concepts. The psychological impact of the findings rippled beyond laboratories. Public fascination surged as images and animations of the object circulated online. Its irregular shape, half-shadowed and enigmatic, captured imaginations worldwide. Yet beneath the excitement lay a subtle unease. If something so alien could pass through our solar system without warning, what else might drift unseen between the stars? And if 3I Atlas were part of a larger pattern, perhaps one day another would arrive. Closer, brighter, more revealing. From a cosmological standpoint, the event reaffirmed that the galaxy is far from static. Interstellar objects like 3I Atlas remind observers that systems exchange matter, energy, and perhaps information across vast distances. The boundaries between star systems are not walls, but porous membranes. In that context, the arrival of such an object was not an intrusion but part of a larger, ongoing conversation between celestial realms. A dialogue humanity had only just begun to overhear. Within NASA's deeper analytical layers, some researchers explored the possibility that 3I Atlas represented a transitional form, an object bridging the gap between inert matter and autonomous system. Certain models of prebiotic chemistry suggested that complex structures could self-organize under extreme conditions, leading to quasi-stable entities capable of self-regulation. If true, 3I Atlas might not be artificial in the technological sense, but alive in a way not yet understood. Its rhythmic luminosity and periodic emissions could then be biological analogs on a cosmic scale, a new form of life written not in DNA, but in metallic lattices and ionized gases. Such ideas remained speculative, but they underscored the broader implications of what NASA's instruments had captured. The debate also reignited interest in expanding deep space observation networks. If objects like 3I Atlas entered the solar system more frequently than previously believed, then tracking them could yield transformative insights into galactic dynamics. Each interstellar visitor carried a signature of its origin, a snapshot of conditions far beyond reach. In that sense, 3I Atlas functioned as a messenger, bearing testimony to environments and processes otherwise inaccessible. By studying it, humanity peered not just across space, but across epochs. The technical aspects of the report also fascinated engineers. The object's surface reflectivity varied in a way that suggested selective absorption of wavelengths. This hinted at materials engineered or naturally evolved to harness specific bands of radiation. Some theorized that such properties could allow energy harvesting or regulation during interstellar travel. Even if accidental, the discovery of naturally occurring radiation management on that scale could inspire new approaches to spacecraft shielding or energy systems. The silence that followed the departure of 3I Atlas from the reach of NASA's instruments was unlike any silence humanity had known before. It wasn't just the quiet of empty space. It was the hush that follows the brush of revelation. The scientists who had devoted their sleepless months to studying the object were left not with closure, but with a gnawing awareness that something vast had just grazed the edge of human understanding. The data poured in, but instead of settling questions, it fractured certainty. For the first time in decades, the scientific community was confronted not with a problem to solve, but a mystery that seemed deliberately constructed to resist comprehension. In the days after the report's release, astronomers from across the world began to comb through the published findings. The paper trails of light curves, infrared emissions, and magnetic readings became a labyrinth that every mind wanted to navigate. Small inconsistencies began to appear, minor variations between NASA's interpretations and those of independent observatories. Where NASA described a gradual dimming of 3I Atlas's luminosity, a team in Chile's Atacama Desert Observatory reported abrupt fluctuations near the end of its detectable phase. The differences were subtle, almost within the margin of error, yet they hinted at something dynamic happening as the object left the solar system. It was as though 3I Atlas was shedding one identity for another, altering itself just as human attention waned. Those who had tracked it longest described it not as a comet, not even as a body, but as a phenomenon. It refused to behave in the consistent, predictable way that most celestial objects did. Some nights it appeared almost tranquil. Other nights its reflectivity spiked as if responding to observation itself. The idea that it could react to attention seemed absurd, yet more than one scientist found that their data changed slightly depending on when and how they observed it. Theories emerged that its surface might contain adaptive crystalline structures, minerals capable of reorganizing molecular bonds in response to electromagnetic exposure. Such materials were theoretically possible, but had never been observed in nature. If 3I Atlas contained them, it would represent a new category of cosmic matter altogether. In a closed symposium months later, one of NASA's lead astrophysicists addressed this anomaly without euphemism. He described the object as responsive in ways that couldn't be comfortably classified as mechanical or organic. The phrasing set off a storm of speculation. A body that could subtly alter its optical or thermal behavior suggested a degree of environmental feedback, even if purely chemical. Some argued that it might be a naturally evolved form of self-regulating matter, a bridge between geology and biology, a phenomenon born not of biology but of physics, capable of maintaining equilibrium in hostile interstellar conditions. The cosmos, it seemed, might be nurturing its own silent, inorganic offspring. Among planetary scientists, the object became a new test for existing models of planetary formation. Conventional astrophysics relied on the assumption that interstellar matter is primarily distributed as dust, gas, and occasional rogue bodies ejected from collapsing systems. Yet 3, i.e., Atlas's density and resilience, challenged that. Its mass was too stable to have survived multiple ejections unless it had some form of internal structural cohesion stronger than gravitational binding. This led to a radical theory, that certain interstellar objects might be formed through self-organizing magnetic architectures. In the vacuum of space, metallic grains could align and fuse along magnetic field lines, slowly constructing lattice-like frameworks over eons. If such processes occurred in the right conditions, they could create dense, self-stabilizing bodies with semi-crystalline interiors. Perhaps 3I Atlas wasn't built, it grew. That notion redefined what natural could mean. If the universe could engineer matter with such precision through the slow grind of time and physics, then the line between design and accident blurred almost completely. Even if it was not created by intelligence, it embodied something akin to purpose, a material instinct written into the fabric of the cosmos itself. Philosophers of science began to grapple with this idea, calling it cosmic emergentism, a concept where the universe behaves like a living system, evolving not just life but pre-life structures that mimic intelligence. Under this lens, 3I Atlas was not a visitor but a messenger of the universe's deeper self-organizing tendencies. The sheer variety of data prompted other avenues of inquiry. Some researchers examined the radio emissions associated with 3I Atlas more closely. Though NASA's official stance remained that they were terrestrial interference, the uniformity of signal patterns across distant observatories contradicted that explanation. The repetition was too consistent, the intervals too synchronized with the object's rotation. Radio astronomers detected harmonic spacing within the frequencies, intervals proportional to prime numbers. In mathematics, such spacing is almost never produced by random natural processes. It hinted at structured modulation, though no decipherable information could be extracted. Still, the fact that the signal existed at all introduced a troubling idea. Perhaps information didn't always manifest in language or symbols. Maybe it existed in resonance, in rhythm itself. Those findings reignited debates about the Fermi paradox and the possibility that interstellar communication might not rely on conventional signals at all. Instead, advanced civilizations, or the remnants of them, might use physics itself as a medium for messaging. Objects like 3I Atlas could serve as carriers of encoded resonance, drifting silently through space until encountering a system capable of perceiving their patterns. It was a hypothesis that bordered on metaphysical, yet it fit the data better than chance. The rhythmic brightness, the frequency alignment, even the non-gravitational acceleration could all be facets of a single unified system of transmission, an interstellar artifact speaking in the language of motion and light. This interpretation split the astronomical community. Some dismissed it as an anthropocentric projection, humanity's eternal tendency to find meaning where there might be none. Others, however, pointed out that human understanding of cosmic communication was still primitive. The assumption that intelligence must announce itself with clear intent could be flawed. Perhaps the universe was filled with messages whose content was not verbal but structural, not spoken but embodied. In that sense, 3I Atlas could be a kind of relic that communicated through its very existence, through the impossible harmony of its anomalies. Behind the closed doors of NASA's deeper analytical divisions, computational models attempted to simulate the object's interior. The data from radar mapping, limited though it was, suggested alternating layers of dense and porous material arranged in patterns inconsistent with impact formation. One of the more radical simulations showed a honeycomb-like core, hollowed yet rigid, capable of distributing external stress evenly. The geometry mirrored some advanced aerospace designs developed on Earth for lightweight structural stability. To see it mirrored on an interstellar scale unsettled even the most rational scientists. If nature could independently create such efficiency, it suggested that engineering itself might be an emergent property of physics. The same solutions appearing across different contexts because they were simply optimal. That concept, sometimes referred to as convergent engineering, proposed that design was not unique to intelligence but to universality. Just as evolution on Earth had independently produced eyes in multiple species, the universe might independently produce similar mechanical efficiencies in matter. This meant that the border between technology and nature could dissolve entirely at the cosmic scale. 3I Atlas, in that sense, might not be an alien artifact but an alien inevitability, a manifestation of order compelled by the fundamental logic of physics. The object's departure left a lingering absence in the night sky, but the data continued to breathe life into the mystery. As analysis deepened, scientists began noticing something peculiar about its chemical composition. Certain isotopic ratios appeared inverted compared to known cosmic baselines. Normally, heavy elements like nickel and iron in interstellar matter decay into predictable proportions over millions of years. Yet in 3I Atlas the ratios were reversed, as though its matter had experienced an unknown process of rejuvenation, a kind of atomic renewal. No known astrophysical mechanism could achieve this without the presence of sustained external energy input. This led some researchers to speculate that the object might have been subjected to, or perhaps generated, its own localized radiation field capable of altering decay rates. That would imply not only endurance but activity, some ongoing internal process that resisted entropy. The concept of an entropy-resistant structure ignited fascination in the field of thermodynamic astrophysics. Such a body, maintaining ordered energy over millennia, could represent a form of persistence beyond biological life, a structure that doesn't live or die but remains in dynamic equilibrium with its environment. In that light, 3I Atlas might be viewed not as a relic, but as a participant in a kind of cosmic metabolism. The universe, rather than a static void, could be seen as a web of processes continually reorganizing themselves into higher orders of complexity. The object's passage through the solar system might not have been random at all, but a phase in that vast circulation, a brief contact point between one form of order and another. Public response, though muted by NASA's caution, found its own rhythm of fascination. Artists, philosophers, and poets turned the mystery into symbol. To some, it represented the unknowable face of the cosmos. To others, it was a harbinger of discovery, a reminder that humanity's grasp of reality was still embryonic. Filmmakers and writers reimagined the event as a modern myth, a cosmic visitation that tested the limits of understanding without offering the comfort of closure. Even religious thinkers found resonance in it, interpreting 3I Atlas as a manifestation of creation's deeper order, something that bridged the material and the divine. But among scientists, the object's silence was the most haunting aspect. For all its irregularities and inexplicable emissions, it gave nothing directly communicative. There was no pulse of information, no discernible code, no acknowledgement of observation. It passed through human awareness like a dream, slipping back into darkness. Yet in that silence lay its greatest power. It compelled introspection, forcing humanity to confront the boundaries of its perception. Every unanswered question became a reflection of human limitation. The mystery of 3I Atlas was not only out there, it was within the very framework of human inquiry. Months after the report's publication, a second, smaller object with a similar trajectory was identified, though fainter and farther. Astronomers hesitated to connect it to 3I Atlas, but the temptation was irresistible. Its orbital parameters bore resemblance, as if it were following a similar corridor through the galactic medium. The thought that there might be more, perhaps an entire stream of such objects drifting through interstellar space, provoked a quiet urgency within NASA's strategic planning committees. If 3I Atlas was not unique, then a pattern existed, and patterns in the cosmos always meant something larger at play. Meanwhile, the theoretical implications of the encounter began to ripple through multiple disciplines. Astrobiology, traditionally focused on carbon-based life, suddenly expanded its scope. Researchers began considering the possibility of mechanical biospheres, ecosystems composed not of cells and organics, but of self-regulating metallic compounds and electromagnetic processes. In this context, 3I Atlas could be understood as a fragment of a larger entity, perhaps a vast interstellar structure once sustained by fields of energy rather than biological metabolism. Such a concept bridged the gap between life and machine, suggesting that intelligence itself might be a property of matter under certain cosmic conditions. Quantum physicists also found themselves drawn into the puzzle. Some proposed that the object's stability could only be explained if its internal particles were locked in a state of quantum coherence, a condition rarely seen outside laboratory settings. If true, that would mean 3I Atlas maintained a quantum-organized structure across macroscopic scales, something thought impossible in the chaotic environment of space. A coherent body of that size could, theoretically, interact with its surroundings in ways beyond classical mechanics, absorbing, emitting, or even manipulating energy fields through resonance. This idea was so radical that it bordered on heresy, yet it offered an explanation for the periodic luminosity and non-gravitational acceleration that baffled conventional models. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on NASA's shocking 3I Atlas mystery report? We want to hear from you. Thank you for watching, and see you next time.